All right, piecewise functions. I never used to really teach piecewise functions because we didn't, well, basically because we didn't have to, but it's turning more into that the AP is starting to give problems more in this format because they're not necessarily trying to test you on contemporary calculus, they're trying to test you on the concept itself. So they're going to give you a graph of some function that would be so complicated you wouldn't want to do the calculus stuff to it. But if you apply the concepts, it's actually quite simple. So you got to have some idea of where they're coming from so that you know what the notation means. And basically what you see there is a piecewise function. It doesn't have to be two parts. As you can see, it's saying y equals x squared as long as the x value is less than or equal to 0. And y will then equal x, and x only, when x is greater than 0. You could have a piecewise function that has 10 pieces. You could have 20. This one happens to only have 2. Okay? And basically what it's saying, I think if I were to ask you right now just to graph y equals x squared, that's it. That's the only thing I asked you to do. I think we could all do that. And if all I did was ask you to graph y equals x, I think we could all do that too. But I'm being asked to only graph them for a certain portion of the graph. Okay? Because let's face it, x squared I think we all know is this, right? And y equals, well, arrows. And y equals x is basically that, correct? But I'm only supposed to graph the parabola for some of the time and graph the line for some other portion of time. And those portions of time don't even have to connect. I can do that any time I want. So basically what I would do is I know that x has to be less than or equal to 0 for me to graph that parabola, right? So I like to go to that 0 right away. Because a lot of times, they don't have to, but a lot of times these numbers here are going to kind of be the same. And let's face it, this kind of means at 0 and to the left, right? This top one. And this means at 0 and to the right. If you translate that, really that's what it's saying, isn't it? And so I start at that number. So start at 0. And this is where I'm supposed to graph it, right? Where that equal to is. So put 0 in there and find out where you're at. 0, comma 0. Now, is that actually a point? Yes, it is. So it should be filled in, right? That's how you've always done dots. When it's actually part of a line, you fill it in. So would it be a good idea to plug, say, 2 into x squared? 2 for an x value. Is that a good choice? Why is 2 a terrible choice to plug in there? Yeah, it's greater than 0. I'm not even supposed to graph it over there. How about x equaling -1? Is that a good choice to put in there? Is that something that's less than or equal to 0? Yeah, you put -1 into x squared, and what do you get? 1. Okay, -1. 1 is also a point. And is it okay to plug in, say, -2? Yeah, because it's less than or equal to 0. Might as well. And it's -2, comma 4. And what some people do is they'll actually just over here, they'll write a little table. Okay, -1, 1, -2, and they'll keep going. But now we're pretty smart. We have a pretty good idea, because doesn't x squared, it goes down, the vertex is that origin, right? So we have a pretty good idea what the left side of this thing looks like right now? Yeah, isn't it pretty much just going to be that portion of the parabola, right? Should I graph anything further right from there as far as a parabola goes? No. And have I taken care of basically all the points that are less than or equal to 0? Yeah, now does it look like a graph of x value of -10? It doesn't look like it, but that arrow means that that thing keeps going up. So, you know, it's obviously -10, comma 100. Well, we're not going to fit that very well on this graph, okay? So are you agreeing that we're probably done with that piece of this piecewise function? So let's go to the next piece. I'm going to do it in a different color. Obviously, you can't do that, but just kind of follow along at this point. I'm only supposed to graph this when x equals 0. But what's the one thing I told you I always do? I go right to that number, graph it first, because I know that's kind of the boundary. I'm going to go right of there or left of there, right? I'm going to do one of the two. And so let's plug in 0. So you put in y equals x. Okay, so if you put in 0 there, the y value actually is. So 0, 0. Now hold on, I'm going to do this one in red. So 0, 0 is not actually a point, so I'm going to put an open circle there, right? Because 0, 0, I'm not supposed to. Why not? Because the equal to is not on there. It's only supposed to be greater than 0, but I plot it anyways because it's a boundary point. Okay, kind of is telling me where to start, or from a different point of view, where to end, if you want to look at it that way. So should I put -1 in here? Is -1 in there a good idea? No, because I'm supposed to graph stuff that's greater than 0 or stuff to the right of there. So can I put in 1? I can substitute 1 in there. And so if I put 1 in for x, y equals, well, 1. So 1 comma 1. Is everybody okay where I'm coming up with these numbers? I'm just trying to keep them simple. Is probably the next logical choice then is 2, right? Because I can plug it in because it's greater than 0. So I put 2 right there, and y equals 2. So it's 2 comma 2. Again, we're really smart. We know what this graph does. It's a line, right? With a slope of 1 and a y-intercept of 0, right? And so pretty much we have a pretty good idea that the rest of this graph's going to do that. So have we graphed the two pieces? Yes, the top piece I graphed in blue, the bottom piece I graphed in red. The key now is we have to put the two together. They're supposed to work as a team, basically. So in black, I'll go through all the points that are graphed. Do you agree that all of this stuff is graphed, right? And all of that stuff. But how about that point right there? That's the point in question, because it's an open circle for one of them. Has that open circle been filled in? Yeah, it got filled in by its partner, right? The other part of the team. And so that counts as being graphed. It got filled in, and then you shoot out that way. So the black one, you notice how the open circle, did I even bother putting it there when I did it with the black marker? I didn't, because did it actually get filled in? It did. That point is there. Okay. Is it possible that that point would have been left open? It would have been very easy to leave that point open, just don't have the equal to on there. Then neither one of these teammates, you could say, would have actually plotted that point. They would have both been open circles. Does that make sense? And there's no guarantee. This is pretty nice. These two actually connected. Right? If you think of like maybe Lincoln Logs or those connects pieces that maybe you had as a kid, Tinker Toys, they actually connected to each other. It's very possible that you could have a parabola and a line that come nowhere near each other. You could have something like this, right? All you have to do is change a few things on that parabola, change a few things on that line, and that's what's going to happen. Okay, and so when you go to make that graph, well, you're just going to go like this. You're going to say, well, that point really never got filled in, so there you go. That's the final graph. Once you put the pieces together, that's just how it works. Okay. But remember, I like to go for that number that they give me there, and I try and plot that first, either open or filled in, and go from that point, either right or left, whichever way I'm supposed to go. Question? These two do. I was giving another example down here where they might not. I was showing you that they don't have to. Right, there's no equal to here. So that kind of shows me it's a boundary point, because let's face it, x greater than 0, I don't want to sit there and try plugging in 0.1 or 0.2, those really small numbers, just to the right of that in this case. So I just put in 0 and make it an open circle, and then I know whichever way I go is going to fill in all those little points that I really don't want to substitute in. Okay? Good? All right. Once again, this one looks a little scarier than the first one. But again, just think of it this way. If I asked you to graph that and only that, y equal the absolute value of x, is that something you should be able to graph? Is it it's one of your parent graphs, right? Which one? Yeah, the v, right? It's the v. But again, I'm only being asked to graph part of it. And again, I think, well, we already graphed that one, right? We're not necessarily going to graph the same portion, but we did graph that one already. Okay? Now you notice I was very nice with the first one, and I made the origin kind of where they connected. There's no guarantee that's where it's going to happen, or like I showed you on this bottom one, there's no guarantee they connect at all. All right? And so start the same way. I'm just going to do it, we'll do it in green this time. We'll just worry about the top piece. So we know it's a V, and we're going to talk about -2. All right, so substitute -2 right there. And what do you get? So again, maybe I'll give you a table this time. -2, and you get 2 because you take the absolute value. That's what you get, right? So it's -2, so you go over to -2, 2. So should I fill that one in or should I leave it open? Okay. Now don't always assume that you fill in the top one. Okay, you got to pay attention. All right? And it's possible you could fill them both in. All right, so just pay attention for that equal to on there. And based on that, should I start trying to get points to the right of that or to the left of that? Which way should I go? It's less than, right? So let's go left. So is negative 3 a logical next choice? Yeah. So you put negative 3 in, and you get 3. All right, so negative 3, 3. Now think back. Again, we're smart. Let's use our parent graphs. We know this is a V. In here, again, if I just asked you to graph that, is there any translations done to that? So where does that V kind of change direction? Right at the origin, right? So don't draw this. But if I was to draw the whole thing, something like that for the whole thing, right? Don't draw that because that's not what we have, right? But really, we're just supposed to graph from there up to the left, right? So, and you told me filled in already, so let's just be smart about it and not waste our time doing that table. We've got parent graphs. We're smart. And the key is to remember, there is no guarantee these are going to connect, but we do know now we're talking about a parabola. And again, did I do anything to that parabola? Any shifting from the parent graph? So if, again, don't draw this, but if I were to draw the whole thing, give or take, right? That dotted line. But we're pretty much not supposed to graph any of that, right? Well, I'll put that green one back in, but in general, that's what it's going to look like. So what I do is I start with that value again. Substitute it in. Negative 2, you substitute it in, and we'll do, maybe I'll go back to the blue, so that's what I had. So here we go. Here's the second piece in blue, color-coded for you. If you put negative 2 into that function, what do you get? 4. Negative 2, 4, open. Yes? That's why we went open with that one. Notice I always put that value in no matter what. And then I have to decide, do I fill it in because it actually is a point, or do I not fill it in just because it's that boundary point because I don't want to put the little stuff next to it in? Because I don't want to have to put in negative 1.9. Okay, so I'm just going to put that in, leave it open. And where I go next will take care of that negative 1.9 for me because I don't want to put those horrible numbers in. So should I go to the right of negative 2 or to the left based on what this says? Go to the right. The nice thing is this kind of points you in the direction you should go. That's the beauty of the inequalities. Go to the right. All right. So put in negative 1. Yeah, put it in there, and you get 1. All right. Negative 1, 1. 0, 0. What's going to happen when I plug in 1, 1? I think you're getting the idea. Do we have to keep going, or do you see it now, I hope, right? So the key is, though, when I make this parabola, should I hit that green point right there? Should I hit, what is it, negative 2, 2? Is that a point on my parabola? No, it's not. So make sure you miss it. You're not going to miss it by much. And that's a little off too, but make sure you miss that. Again, doesn't miss by much. So do these two connect? No. That's okay. And so when I go to finish this one off and do it in, and you only have the one color, so you're pretty much done. But as I go to finish this one, yep, I got all that. I've got all this. And at any point, does that one get filled in? No, that circle never gets filled in. The teammate doesn't do anything with that. And so it's just that point, no, well. Now, are you having any questions? Okay. Then what we're going to do here is I'm going to leave a couple for you to do for tomorrow, but we are going to first come back to this one. So please go back to example 1. Because believe it or not, piecewise functions still have domain and range. Does it get a little bit more complicated? It is a little bit, but it is still important to be able to do it. So now that's kind of why I came back and made a solid graph like the black one. Okay? So as far as domain, again, that's left to right. And we talked about negative 10 already. Does negative 10 actually pop out a y value if you substitute it? It does. But really, you're only plugging negative 10 into this top one. You would never plug it into this one, ever, okay, because you're not supposed to. So as you go left to right, do we come across any problems? Because that one point actually did get filled in, right? It got filled in. So 0, if you put it in there, you have to put it in this one but it does pop out a y value once you put it through that. So domain, Tabitha's favorite. Yep, forever and ever.
Oh, Anna.
Range, again, that's bottom to top. So how about negative 7? No. And you work your way up, and the first one you actually run into and does that, and you're sure that actually is a y value that does happen? Yes, okay, so it is a bracket on 0. And then does it go all the way the rest of the way? And in fact, the rest of them get graphed twice. The rest of those y values get graphed twice. Like for example, 2 as a y value gets graphed here and there, so they all get taken care of. And so infinity. And how about this one? This one's a little bit more complicated. Sure.
Negative infinity 2. Negative 2. It's negative 2 bracket, and then another one. Negative 2 not including it to infinity. No. Okay, I'm going to say this wrong, but I'm going to do this. Where does the maybe? No, there's 2 infinity.
Ah. Nicely done. This is a hard one. Domain's tough. I wouldn't fault you for wanting to say negative infinity to that negative 2, because there's a problem there, right? Something's going on. But does the x as negative 2, negative 2 is right here, right? Is there a y value along there somewhere? There is. It's right here. So does negative 2 actually in one of those give you a y value? It does. Does it miss here? Yeah, it misses. Very true. But negative 2 at some point gave us a y value. Okay? So it is correct. They are all used, I guess you could say. All x values get used to produce a y value. Now I guess the question is, are all y values produced? Maybe that's another way I could say it. No, there are some that are missing. And so once again, we go from bottom to top. And again, these negatives, nothing happened there. And so the first one you'll run into is, again, now the question is, can I go all the way to infinity? So you're saying this hole here, once again, does not cause a problem? No, because actually that particular y value gets taken care of twice. What y value is that? 4? That y value gets taken care of twice. It gets missed right there, but it gets taken care of everywhere else. Okay? And so it is actually the same. Okay? Your job for tomorrow is letters C and D. Okay, we can talk about y equals 1 very quick. It's y equals a number, horizontal line. Y equals 1. This is x equals 1. This is y equals 1. But make sure you put it at the y value of 1. But only for a certain amount of time. Wherever it's supposed to start. What x value are you starting at?
1.